Let me point out, I'm going to help you recall what we have done. This is ER diagram, right? This is ER diagram, and the lower, this is to get the ER diagram, the process is called the conceptual design. So this is a conceptual design. Uh, yeah, output of a conceptual design is ER diagram. So ERD. This is our outcome. Once we have a conceptual design, then we need to do logical design. Outcome of a logical design is relation schemas. Relation schemas. A relation schema is a set of attribute, like this attribute, or together with its type. So usually we start from the conceptual design, followed by logical design, followed by implementation. So to do implementation, we need to choose DBMS. In our case, MySQL. Chosen. MySQL is very nicely adapting relation schema, the schema that we have. So we will not have any problem. And then to implement the database systems that we need to use DDL, data definition language, to define database. Once database is built up, then using DML, data manipulation language, to manipulate the data. So two languages that we are going to work on today. So DDL and DML. So these are the DDL. Let's see, if we have a student, then we need to create a table, right? So CWID name and major. And the definition here is really, really minor. What that means is that we didn't define anything about the primary key, anything about the foreign keys. So we will do in our hands-on little more than this. Okay, but I want you to see we need to create tables. Once we create table, then we need to populate the data, insertion. Okay, these are the insertions. That's what we did the last week, right? And I asked you to complete yours, but we will do redo. Okay. So before we get to that, I will go back to bring up and start. I mean, log in by SQL, right? Those who have a MacBook, you can follow like me. Those who are working on Windows, then you first need to find out whether your MySQL is up and running. Usually that is in program files for Windows systems. Program files, that is a top level, one of the top level directories. And then there is a MySQL, and then see a specific version of a MySQL. In any case, you go to where there is MySQL and binary directory. The path expression till MySQL different, depends on your platform. For Mac users, USL local. And after that, I believe MySQL. No, that's after this. MySQL is a directory, and then bin is a directory. And then there is one specific application program that we want to run, which is MySQL. This MySQL program will take parameters, options, username, and then for authentication, this guy wants to use password. So password-based authentication. So hit enter, and then I can enter the password. All right. So I am in MySQL. In a given database engine, there may be more than one application database. So we want to see it. Show databases, the list of databases. Tables. Show tables. I have a course department, enroll faculty, students. I want to see if there is anything already populated. Course, there is nothing populated. Then I need to do insert. If I insert, I need to do, I want to see the schema of table course. Accordingly, I can insert data. So insert into course. If I want to enter the value in the order as defined from top to bottom in that table, then I need to simply values, title, foundations. CRN, that is integer. That's a key. I can say 1, well, I'll just say 505. Credit, 3-hour credit. Hit enter. But I want to do more than one at a time. So for example, advanced database, that is 525 and 3 credits. Let's do only 2 courses.
A bracket.
I did one more bracket. There is a reason. So if I do select start from course, then I had to, again, show tables. I have a course and department. Let's see if I have any population into the table department. No department. So I want to do insert into department. Again, before I do, I need to see the schema. Two attributes. And name cyber dispatcher, right? And chair Uzman. Let's see. Oh, missed the values, right? I want to put one more. CS, department chair, nursing. Enter. Fine. Show tables. Enroll. Probably. Okay. Before we do enroll, we need to see the faculty and student. Okay. Then values department to cyber and one, maybe three more. Peter, maybe more. Semicolon. Got it. And then we have students, right? Oh, we have those students. Okay. Now enroll. CRN. I want to see. Five oh five and 25. And the students, those are. So insert into enroll values back here, CRN first, and then students, right? CRN, let's say 505, enrolled by, we have a faculty John and student John. Okay. Not a problem. That also realistic. And then even in the cyber department, there are two the people with the same name, two students with the same name, John, and also faculty name, John. And then John, what actually three students in cyber, right?
They are your.
Right. All right. So 505, maybe 2111 is also enrolled, and 525 and 2111 also enrolled. And CS John So 505, 1113. Let's see that many. Okay. So a little bit of the data populated. So those are the DML. Now we'll look at the oh no, DDL. DDL has been used right now, right? So DML. One of the typical DML is SFW clause. S for select, F for from, and W for where. Okay. So SFW. In the clause of select, well, we need to list attributes. In the from, list of a table, and then where the conditions. Okay, so select from where clause. So let's take a look at here. List the courses taught by John. But actually, we didn't do anything about the instructor for the course, right?
And you just do the courses taken by that.
Instructor. One of the, yeah, we can alter, but I'm not sure. If we do alter and then
Alter update.
yeah, no. It takes a little longer time, right? I need to recall the language. So it is alter table. I think add the attribute, something like that. So to make sure, we need to see clear the language. MySQL alter attributes. Okay. So it should be, oh yeah, alter table name, add. Okay. So we can follow that. Alter table course, add instructor. Instructor would say instructor's name. Instructor, where is instructor? Instructor. Faculty name. Oh, that's not primary key. So we can simply say text. Great. So description faculty, then, oops, was not.
That's the step course.
Okay, let's see. Alter table name, add name and that. So it's alter table name, add. Let's say, should this add the column, add the email. Is it a course?
You're doing description department. So of course.
Course with title, CRN, credit. So we need to do, oh no, we need to see, right. Yeah, we have instructor. Oh, we did it correctly, right? Okay. Now we need to add, right? So this is a little bit trickier. So what we need to do is we need to we need to use update update because we need to insert the data specific into the specific row. So we need to update course. The language. It's a language issue. MySQL update. We need to use a specific update the table name set. Okay. So what we need to do is update table name, set instructor equal in the course. We have only two courses, right? The course 505 and 525. Okay, nice. So let's say instructor is John, where CRN, where CRN equals 505. So 505 is taught by John. That's what we want to show. So select course. Let me see, John is teaching that. Similarly, here in this case, I want to change it. Who are the faculty right now?
Chris. David.
Oh, David there? No.
Yeah, David.
Oh, okay. Suhada.
David.
Peter. Okay. So let's do Peter. Instructor Peter and CRN 525. Okay. And then I want to see the course. Okay. Peter is teaching Advanced DB and John is teaching Foundation. Okay. By modifying that, we can see a list of the courses taught by John. I want to see some of the courses taught by more than John. In order to do that, it's a little bit more, right? Insert into course values foundations okay, let's say AI. CQAI. There's a course, CQAI, CRN. We do not have that, but let's say 555. Let's put something that we have. Let's say that is taught by Bob. Bob is there, right?
And David. Power credit.
Yeah, credit. Okay. What am I doing? Oh, when I list, if there is more than two courses taught by John, then maybe a little better. So I want to put more. Here, John, and is teaching actually 520, and then data mining. Okay, so let's try to see here. So list of the course taught by John. if it's the course, then course these things and instructors, right? So we need to make sure list of course, then we can list of those taught by John. So John is in this description of the table. So we don't need to bring more than one table. Simply from one single table, we may be able to get the information, right? So select star from, for example, course, then we can list all of those. But I want to see only taught by John, right? These two. So how can I get them? That is to use not only select from, then we need to have where clause. Okay, so we need to put here where. So what should I do if we say the conditions? In this case, it says taught by John, right? This is the condition that we want to use. So John should appear in which attribute, which column? Instructor, right? So we should say here instructor equals and then John. Hit enter, then we can see only John. If we want to see, hey, is there anything that we can do like starting with John? Is it percent sign? Maybe. Yeah. It's not the wildcard star, okay? In database, we use, if we say this, then it doesn't give you any, right? But if you say star means there is one single character. So that if you say star, 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 oh, star doesn't work anyway. So this percent sign, okay? That works. If you want to see, if you do not know, but you want to find some names start with J, then J and percent. So percent is wildcard. Instead, here the operator, rather than saying equal sign, we need to do like. Okay. So a little more like our spoken languages rather than symbol, right? That's what we have here. Okay. Next one. List the students who study the cyber major. That we can find out, right? Students. So when you see this, then you need to see, oh, student has what? Student has a CWID and name and major in our definition. Oh, we have age a little more. Study, which is a major, right? Cyber major. So can you get it? Oh, yeah, we have a major here. So, but we don't need to bring any other table but the students only, right? So we simply do the same similarly. Select. Again, here, star means you want to see all, but if you want to get only name and age, list two columns only. If you say star, then you want to print all the columns. Let's do all the columns first. Star from student where major equals cyber semicolon. Then you may be able to see only those who are in cyber. They're all John, right? But if you want to see, hey, why should I use cyber again? Because I try to see cyber, then major column may not need it. Then you need to list out maybe name, age, You can say like this. Name and age. Rather than CWID, you may be able to say CWID as code. Whatever you want to hide this column name. CWID maybe that is important to the attributes that may give a hint to external attacker, so that if you do not want to show it, then you can hide it in this way. Okay. Any question about this simple SQL language? Then move next. Join tables. Sometimes we may need more than one table to be considered. For example, list students with the course title, student information and course title. If we see the student table, then there is no course information. Course title is only available here in course, right? So at least I need the course and student, two tables. Okay, but they are taken by students, by the students. So they should be linked between course and student. But if you see this attribute among, between those two tables, there's no common attributes based upon we can describe the relationships between course and student. Okay. And also, if we go back to our original ER diagram, then student and course, one student, each student takes more than one course. Each course can be taken by more than one student. So this is a many to many relationships. Because of this cardinality, this relationship diagram, diamond, is not removed when we do this logical design, but it is converted to as a separate table, right? That's what we did. So to represent that relationships between student and course, those two tables are not enough. So we need to bring enrollment. We know that, right? So by having this enroll, CWID comes from here. CRN comes from there. In this way, those originally, course and students, those two objects can be logically connected. Enroll itself may not be a visible object, right? But I should not say visible. Course is not visible either. But anyway, yeah. So through CRN from between course and enroll, through CWID between enroll and students, course and students can be related, and therefore we may be able to get the information about student and course. Okay, so select star from student and first of all, let's try to this. See what happens. If I do this, what would happen? Number one, it gives an error. Number two, it gives an answer. Number three, it gives a lot possible combinations. Number four, whatever. Which one is your answer?
If everything from student import.
I think, yeah, Noor, I think he knows that. So if I hit enter, then all kinds of between course and students, all kinds of combinations. Watch this. Can you see there are some nonsense? Nonsense that you can see here. This is student and student major titles here and instructor. Okay, so one of the nonsense is here. John, same John, right? He takes everything. CWID 1111, CWID 1112. He takes all. CWID 1113. He takes all. Everybody takes all. 2111. He takes all. 22111, 2323. This means all possible combinations. To avoid that, what should we do? We need to give some relationship, right? How they are related. In order to make them related, then we need to have here enroll. It's not necessarily enroll should be in between. Logically in between, right? So where, let's say we simply bring enroll, see what happens. Even worse, previously how many rows? 24 rows. Having one more, 96 rows. Now you may be able to see what you need to do if you pick one of those. So now attributes that we have here, CWID name, age, major, title, CRN, credit, instructor, CRN, and student. I want to, okay. The first, if we see first row, maybe okay, but maybe okay in terms of a CRN or CRN. Yeah, this guy talking about CRN. What about students? We are now student John, who's a CWID 1111, but that says at the end his CWID is a 1113. Okay. And then same that guy, the first row, look at the first row, and then I will highlight. First row and then row that I highlighted, they are exactly the same all the way to the last two column. Here we're talking about 505. The all of a sudden 525. And then student ID also 21111. So in what way they are this guy, this currently, if we simply say select star from list of tables with no where clause, then it gives me all possible combinations, right? So how can we make the result more sense? Not more sense. How can we make the result perfect sense? Correct sense? Not all possible combination, but if we say CRN here, that CRN should be the same as CRN here. This CRN, that CRN should be the same. Here, STUD, that's a CWID. This is CWID and that CWID should be the same, right? To link them properly, we will get the proper answer. So in the where clause, we can say student CWID should be the same as involves to and I want to oh yeah, I know. Oops. And enroll to do should be the same as no, not enroll to do enroll CRN should be the same as course.crn. Yeah. Oh, that makes sense, right? So what did I say here? Students, of course, yeah, who is taking what? So John is taking John in cyber major, who is 21 years old, take 505. John, same age, but different John. CWID is 211, 111, 505. And then that guy, the same guy, takes one more course, Advanced DB. And then there is a computer sciences John. We do not know the age, but he takes also 505. Okay. So one more thing. If we describe this condition and that conditions, it's a little bit, I have to type a lot, right? So in order to, if we have the long list of the conditions in the where clause, then we need to make some acronym. Student S and course C, enrollment E. Then we do not need to say, we do not need to spell out student, but say S for student, E for enroll, and then C for course. Okay. This is simply the human friendly. Okay, what else? Any questions? So we need to have here the where clause, from clause, select from where clause. In the from clause, more than 2 tables, so that we can join them. And if we have an extra condition, then we need to put that condition there. Let's see, we don't have that. So what if we say list of the student who is older than 21 years old, older than 20, older than, oh, they're all 21 years old. What else that I need to say? It's not good examples. The CRN number is less than 510. If we need to say that, okay, then we need to say all the same 2 conditions in the where clause, all the same. Plus, then we need to do and CRN in. Let me clean this a little bit more. If we say select star, then there's a long list, right? So I do not want. So for example, I want to get enrollment to the list of attributes and the student's name. And then course title. And then course CRN. So much, I mean, it's a smaller list, right? Within that, I want to say the where clause. No, in the where clause, one more condition. CRN number, because CRN is integer, right? So that I can put here CRN is less than 510. Then I can ambiguous, it means which CRN are you talking about? So we can say course.crn. Then there's 510. 510 course only. Okay. Give me 1 minute. I need to answer. This guy keep calling me. Hello.
Oh, you're saying, start.
Oh, yeah, so what I was saying is like, yeah, you wanna learn it, which is fine, of course, but like, just to keep it simple, like and then it'll throw, if you're in the midst of like actually doing everything, like you should be doing, because we want to be proficient, both knowing that and knowing how to do it, not just the information. It'll throw you extra time as you're in progress, which I didn't know. So like when you think you're like running out of time and you're like panicking,
That's
it's like
so annoying.
here's another 5 minutes, and I'm like,
Yes, I believe 10 minutes.
just give me the fucking time.
Doesn't mean we add more time, right?
Yeah. So it adds it on there.
Sorry.
Which is nice, but it's like, yeah, it's like you're freaking.
This was yeah. I let my son-in-law drive my car, but he got the accident.
No.
So
Is everything okay?
it happened during weekend, but it's insurance issue. Insurance, because I didn't drive, but all right. Okay, any comment, any issue? It's clear, right? So SQL is very straightforward, a very simple language. If you compare that with the regular host language, for example, Python, or even other JavaScript, for example, then this SQL is much more simpler. So although this is a little bit longer expression, that my highlights there. Even if that is a longer expression, but okay, let me explain in this way. To the database engine, or to the computer, for example, this language is not going to work as is, right? This should be internally converted to, for example, C or Python, at least. Should be converted. Why? This SQL statement does not say how to manipulate. This is simply say, this is what I want. But computer does not give you if you ask what you want. Now, because OpenAI is involved, so a little different. But anyway, even if OpenAI involves, but internally, it should be precisely describes how to do, right? Why OpenAI is intelligent? Because OpenAI knows how to do on behalf of us. We don't need to say, but OpenAI takes care everything about our details. Same thing here. All details should be handled by DBMS. So internally, this is converted to. So this is, if you see that whole SQL statements and try to think how it can be processed if you convert that to in Python. This is not simple code, right? So long list of codes. At least it is longer than this code itself. Anyway, so SQL is a simple language. We call that it is called a descriptive language. It is not procedural language. There's no process details stated, only descriptions. Okay, let's move. Why join conditions? We looked at that, right? Unless otherwise, purchase some products returned, as we looked at, right? Let's see here. Where is my? Okay. We need only, yeah, four rows to be expected, but all of a sudden 96 rows. They are a partition product. Someone may think, why then partition product is first given? Someone may say, why not even our DBMS handles clean up all those partition products? Why it started with the partition products anyway? If our database is intelligent, for example, then why should we build from the beginning, not include all those partition products? So make everything should be made a good sense. You may ask that question, right, to yourself. Can anyone think why? Why DBMS, although DBMS being evolved, being enhanced for the last several decades, still, if we describe more than one table, then it first return. If we do not say anything about the join condition, then by default it gives us that big nonsense, but all possible combinations to us. Why not? If anything a little bit advanced, then should we clean that out, right?
I would think it's simple by nature on purpose.
Yeah, it has a purpose, of course.
It might be obvious, but just to, like you said before, input output, right? So it's like simple in, simple out instead of like really overcomplicating things, because I think if you start putting more complex things into it.
Yeah, right. A little bit closer to the answer. So the idea here is this: without saying any specific condition to be described, then give everything, all possible conditions, and then we human database user now think eliminate. I want to eliminate this. I want to eliminate. What that happens along that process, I do not want to eliminate this. I want to still describe this. If DBMS by default gives all clean shots, then there's no such things that we could do. Like this time, like this current DBMS, it gives me all possible. So we now can do by deleting this at one reason, by deleting others at another reason, I can manipulate so that I may be able to see something. This is a join table that we looked at, right? This is something, okay. Something like this. Left side, that's a join. Right-hand side. For example, David. This is originally Adam name and title. Name and title. So who teaches what? Let's find out that. Who teaches what? Then we can say select faculty name and course title from faculty F, course C, where faculty name equals course instructor. Hopefully this works if I don't mistake. Oh, okay. John teaches foundation. John teaches data mining. Peter teaches advanced database. Bob teaches mobile tech. Okay. In the faculty list, we have David. David doesn't teach. Okay. I want to see not only if we perceive all possible combination by having this, all possible combination. See what? Still David teach, right? All, because it is all possible combinations. Why? Because we have how many faculties? 4 faculty members. How many course? Maybe 4 courses. 4 times 4, that's 16. Yeah, 4 courses, 4 courses, 4 faculty members, so 16 all possible. If we doesn't allow this all possible combination, then we cannot get this. For example, something not exist cannot be identified from the database. What I mean by that is what we can get from database is only what it contains, what it relates. But I want to see what it is not related. Is there anything unrelated? Do you understand? Right. Peter teaches, for example, Peter teaches mobile tech. That is something related. But what doesn't related in my database is David, because David didn't teach anything. But it shows David teaches this and that and that. From these all possible combinations, we can at least see some unrealistic by describing this condition in the where clause condition. In specifying where clause, then we can see, oh, they are related. Without this condition, it gives me all possible, somewhere in between, left join. I want to show, although something not related, that left join can be done like this. We have here select to join, left to join on. Select from where clause. So we have a select from, rather than where clause, we have left to join in the from clause. We can say left to join and on. So watch this. So here, left join. So that I can see, oh, David is still included, but he does not teach. Do you see that? These two things. This is a regular join operations. By including this where clause, so we can get all that makes sense. But I want to get something in terms of a database perspective, no sense at all. But because database join operations gives me Cartesian products, all possible combinations, so that I can still keep the left side. In other words, faculty side, I want to keep it. No matter what, I want to keep all the list. John, David, Peter, Bob, like faculty has a John, David, Peter, Bob. I want to keep the left side table, faculty, and then on the right-hand side, if it is matched, I match it. If it doesn't match, I simply say no. Okay? Therefore, DBMS by itself should not be intelligent. If it's intelligent, then there's no room that we can play something something meaningful, but unusually, like this. For example, I want you to consider the university database as a administrator. Administrators, I mean, consider two the faculty members. One faculty takes administrator role. Another faculty member takes teaching role. Faculty as a teacher concerns student enrollment. Student enrollment. Who comes my class next semester, for example. Faculty as administrator's role concerns who does not come back to our institution next semester, rather than who comes in. If a student comes in next semester, they don't care, because anyway, students comes, right? That keeps enrollment healthy. What they are concerning is somebody who do not want to come back, then they want to see it. That type of information can be seen like this, right? Who does not teach, rather than who teaches. Okay, aggregation. Aggregation is what is the aggregate function? Aggregate. Aggregate means we want to collect, right? If we say aggregate function, then that is the function takes as many cases as possible, but it returns only one number. takes as many possible, returns only one number. What kind of functions are aggregate functions? For example, sum. Give me sum, total number. Doesn't matter how many, but the answer is always one number, right? What is the average? Then that is one number. What is the maximum number? There's one number. What is the minimum number? There is one number. How many students in your class? There's one number. Who is the oldest students in your class? One number, right? What is the average score of the midterm exam? One number. Those are all called aggregate function. Aggregate. Database gives you the way to handle aggregate functions. Okay. So here, see title and for example, C dot credit. Then we can see John teaches foundations for 3 credits. John teaches data mining for 3 credits, and so on and so forth. But sometimes administrator wants to see not the list of those, but why don't you, how many credits are taken by which faculty? How can you see that? Then that is aggregate functions. In order to that aggregate functions, then there should be group by, okay? So you can say here, group by, for example, name. I want to group by. If you want to group by name, then John, then group them. So credit is 3, so it'll be 6, right? So group by name, and then that credit should be, you need to say sum. Of course, later it should be group by faculty name. If we do this, then what happens? It gives us an error, definitely, language-wise. Why? Oh, it was smart. Because of this title, the answer that we expect, right? These 2 rows should be merged into one, and then credit should be added to 6. But if we list the title, then my database may have been big trouble. How can we combine these 2? What that means is that if we say group by, then because we are talking about aggregate function, something that cannot be aggregated should be removed. So credit can be aggregated. Name is not aggregatable attribute, but name is already used here in group by. So attribute used for group by, that is okay. That should remain. Other than that, all others should go away, except only something that can be aggregated. Do you guys see? So if you hit enter, then we can see 6, 3, and 3. If someone wants to see then that makes more sense, right? Oh, total. Total credits. All right. So that is aggregate functions. Now, can you see also not like this? Then we need to work on here, right? Above somewhere here. That left to join. In this left to join, let me go back here. I want to do aggregate functions, similarly that we did. So we need to do here group by f dot name. And then back here, title shouldn't be, but we need to have sum and as total credit. Okay. Then something that's some left to join. Oh, we didn't use that once. We need to use the left to join. Where is the left to join? What did I want? It should be left to join, right? So let's fix a little bit here. Course and left to join. We need to say on. Okay. So we could see John total credit is 6, Peter 3, Bob 3. If you compare these two, if you did only the regular join operations, so select from and where close, then you see something that related in your database. But if you do left to join like this, not only something related in my database, but also something not exist. David, the credit information never existed in my database, but I still take it. It was possible because my DBMS started with Cartesian products. This guy gives me a little involved with three tables, but this is my example here, simpler so that you can understand better. Question? Yeah. As a nutshell, that's what we did. I think this is all that I prepared today's lecture. So, any questions so far? I think this is yeah, from the simple SQL to complicated SQL expression that we did it like this, complicated expressions. we covered them all. But now you need to practice. Your practice will be done by the homework assignments. Okay, so I will give you the homework assignments based on what we learned. Very similar to this, but I'll ask you to do. Okay. If you guys do not have questions, I think this is it for today.
Also get related with Python. So like MySQL, we can write functions in Python and bring it here.
Not in this class. Oh, by the way, we have operating systems. So this is a database portion. So database portion is done. We have another class called advanced, no, not advanced. It is called distributed databases and security, 525. Yeah, they're starting with SQL, but we include SQL in our host language programming, particularly Python. So everything that we could do can be done in Python. So we're not working on this SQL, MySQL prompt. We simply run Python, then Python access database and bring the result back. Okay, so this is done. And let's move back